All right, I'm going to take you through how to do this a few times here, how to graph sine and cosine functions quickly using the drawing the stretched version and then doing the shifts. So remember, this was all about acknowledging the amp and period to start, and then we do the shifts, the left and right or up and down. So I have 3 examples here written out. Again, the first thing you're going to do is look at the amp. So the amplitude here is 2, and the period is 2 pi divided by k, and the k here is 3, so it's 2 pi over 3. Just for our thought process, that's 120 degrees, 2 pi over 3. And for the future, I'm just also going to acknowledge this. This shift is pi over 6, and the shift and the period are kind of the things that affect how I label my x-axis. So pi over 6 is 30 degrees. So based on what I can see right now, I'm thinking to myself, I'd like to make sure that my graph goes up by intervals of 30 degrees. It'll make my math be a little easier. Okay, so the stretch version, I know it's going up 2, down 2. And I need to have something that goes up by 30 degrees interval, so I'll make this pi over 6. 2 pi over 6, which is pi over 3. This one's 3 pi over 6, or pi over 2. 4 pi over 6, which is 2 pi over 3. 5 pi over 6, and 6 pi over 6, which is pi. We'll let that be for right now. It's a sine graph, so sine graphs do this. They go start from the middle at 0, 0, then they go up, then they go back down, and then they come back to their equilibrium. So I'm expecting this to start here. My period tells me that it's supposed to take a 2 pi over 3. So from here to there, it's supposed to do the full period. So I'll put my second point right there. All right. So I have this point and that point. Now I want to find the point halfway in between them. So if I look at this, this is halfway between those two. So I have that point now. Now I want to find that peak, and that peak should happen right here, halfway between those 2 points. And it's an amp of 2, which means my graph should go up to 2. So right here, it's going to hit positive 2, and then I got to find this point. So that's halfway between this point and that point, and that's right here. There we go. So we draw up, down, and so on. That is the stretched version. Now what I'm going to do is do the shifts. So this is saying pi over 6, it's minus, so it's pi over 6 to the right. And this says 1 up. Okay? So we have pi over 6 right. Remember here on this graph we made pi over 6 to equal 2 units there. And it's 1 up. So I'm going to take this point, I'm going to move it over 2 to the right and up 1. And take this point, move it 2 over and 1 up. Take that point, move it 2 over, 1 up. Take this point, move it 2 over, 1 up. And take this point, move it 2 over, 1 up. And then I'm supposed to, usually I ask you to draw for 2 cycles or something like that. So we're just going to continue this pattern. So you can see for every 2 units we move over, this graph makes a move. So right here, it would be at a minimum. Right here, it would be back at its equilibrium. 2 over would be at its max, then its equilibrium, then its minimum. There we go. And that's our graph of y equals 2 sine bracket 3 bracket x minus pi over 6 plus 1. And I'm slowing down in my speech there because I can see a mistake there. I didn't count over 2 properly. So I'll quickly fix this for a second. I'd hate to have a mistake here. All right, I'm going to get this right. Here we go. So 2 over, 2 up, 2 over, and then it's up here, 2 over, and it makes its move again. 2 over, it makes its move. And 2 over, it makes its move. There. And I noticed my mistake because I looked at the overall picture and it just didn't seem like it was repeating itself perfectly. So do the same thing. Look over your work. Okay, next one. Again, we'll look at the period. So the period for this one, and the amplitude. So the amplitude is 3, the period is 2 pi divided by this 2 right there. So it's pi, which we might think to ourselves, every 180 degrees it's making a move. Remember, we look at these horizontal things because it's going to affect how I label this. And pi over 4 is 45 degrees. So I think to myself, right, I probably don't want to count by 30s because then it's not going to line up nicely with the 45. I see that it's also shifting down eventually, so I'll put my x-axis a little higher up. And here we go. So I'm going to go up by 45 degrees. So that's pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 6 pi over 4, which is 3 pi over 2, and 7 pi over 4, and then 2 pi. All right, our stretched version. Here we go. This one's cosine. So cos, we expect to start at its maximum, come back up, and go like that. So this one we're thinking about, how do you transform the point 0, 1? So if the amplitude is 3, it's not going to start at 0, 1, it's going to start at 0, 3. It stretched it vertically by 3. Then we look at the period, and the period is pi, which means that the distance from here to that pi right there should result in a full cycle. So there's our other point. So we just acknowledge that one and that one. Now I need to find this point. So halfway through between those two, it's supposed to hit a minimum. And so at pi over 2, it hits -3. So I got this point now, and then halfway between the minimum and the max, we're at the equilibrium. So we should be at the x-axis. Here we go. All right, that's the stretch version, but now we need to do our shifts. And our shift is pi over 4 to the, it says positive, so it's left, and it is 1 down. So pi over 4 to the left. Again, we've defined here that pi over 4 is 2 of these units. So we're going to go pi over 4 to the left and then 1 down. So we just took that point, moved it 2 left, 1 down. Take this point, move it 2 left, 1 down. Take this point, move it 2 left, 1 down. And we just keep going until we finish this. So here's my picture right now. This is one full cycle. And again, if you're noticing, I like to use this language of like what happens every move. So every 2 moves to the right, we make a move. So 2 over, we're supposed to make a move, and it's going to go to the equilibrium. And then 2 over, it's going to make a move, and now we're at the minimum. So these are the minimums right there, right? This is the equilibrium line. So it's going to be 2 over, it's going to be back at the equilibrium, 2 over, it's going to be at the maximum. There we go. That is the stretched and shifted version. So the purple graph is the final version. All right, last one introduces a bit of a funny concept that I find odd for a moment. It takes a little bit of mind thinking to go through this. It involves 2 little tricks. Whoa, that's not a straight line. All right, same thing. We're just going to say what's the period, what's the amplitude. So amplitude is 2. I know it says negative there, so I'll put that behind. The amplitude by definition is positive 2. It's a measure of distance, so it's positive 2. But we'll acknowledge it's negative in a moment. And then the period is 2 pi over k, and here we have k as pi, so it's 2 pi over pi, which is 2. A little weird, we don't have a pi anymore. So the period is 2. The shift is 1 to the right. And you'll notice there's nothing on the outside, so we're not going up, we're not going down, we're just staying put where we are. So how do we label this? Well, the period is 2, and the shift is 1. You'll notice we have no pi's going on here. So this is a very different graph than what we're used to. I said I like to divide this by 4 to figure out what I'm going to go up by. I've said that before. So that means 0.5 is kind of ideal to go up by. So I'll put a tick there, and then I'll put a tick there, and that's 1, 2, 3, 4. Okay, and then here's our 1, 2, 3, etc. All right. So the stretch version of this one. So the stretch version, it's sine. So sine goes like this and this, like that, right? However, it's negative, which means that everything just reversed. So it still starts in the middle, but now it goes down rather than up. So it's going to start at 0, 0. Amplitude is 2. And the period is 2. So again, we acknowledge, okay, the period tells me that in 2 movements on the measurement there, we should have a full cycle. Oh, it looks like I made a mistake. Oh, no, I didn't. That was good. So we start here, and by 2, we should be back to where we started. So we just acknowledge this point and that point. Now we're going to find the point halfway between them, which is obviously right there. So we got that point. Now we're going to label that point, which is the minimum. So remember we said it goes, the amplitude is 2, but it's reversing. So it goes down to the minimum, then it goes up to the maximum. So up to right there. And here we go. That's our graph of the stretch version, obviously. And now we got to take care of this one right deal. So 1 unit to the right means that this point is going to go over there. That's 1 unit to the right. Don't count the blocks, right? Talk about your measurement. So that means actually moving over 4 blocks. So this point is going to move right there. This point is going to move over as well. So that point goes right there. This one moves 4 units to the 4 blocks to the right, right? And then here we go. So it looks like this. And then the pattern continues. So again, you can see that every 1, 2 of those blocks we make a move. So every 2 blocks, I got to make a move. 2 blocks over, make a move. And there we go. So that purple version there is the final version of y equals -2 sine bracket pi bracket x minus 1 bracket bracket. The thing I find unique about this one is just acknowledging the negative and what that would do. If it was a cos curve, instead of starting at its maximum, it would start at its minimum. And another thing that I find unique here is that when there's a pi in the k value, what happens is the period ends up just being a nice whole number or a decimal number, but there are no pi's left. So whenever k has a pi in it, we end up eliminating the pi, and our labeling system gets a lot easier where we're just working with 1, 2, 3, 4, or some whole number like that rather than the irrational pi. So I hope this video is helpful in helping you quickly graph sine and cosine curves.